when you turn on your calipers, first thing you want to do is take your finger and run it along the jaws in case there's debris set up that can give it a faulty zero measurement. There's three primary ways that you can make measurements with calipers. One, for making measurements where you can put pieces between to get a measurement like this. You can use these pieces to get a radial measurement for the inside of tubes, like so. And then the stick at the end can be used for measuring depth. G34, we have two types of saws. We have miter saws, which are used for wood in these miter boxes. These allow you to make straight cuts within the miter box, either straight on or at certain angles. The guard at the top of the saw prevents the saw from going deeper than the height of the box itself. So you'll use these for cutting wood. The other type of saw we have is a hack saw. This is used for with materials in the table vise, and also for cutting harder materials like plastics and metals. Importantly to note on these saws is the direction of the teeth on each of the blades. There is a directionality for saws, and so you're only supposed to be cutting in one direction in particular. So on the miter saw blade, it's always in one direction. On the hack saw, you can switch the direction of the blade. You can flip it one way or the other. Just look for the arrow to indicate the direction that you should be making cuts. So first, we're going to look at cuts using the miter box. So the miter box, which I've already fixed here onto the table with these large C-clamps, is a nice box that allows you to make cuts at various angles. So you can cut at a 90 degree to the block, you can cut at 45, and so on. To set up your block or your wood in the miter box itself, you can use these cam pegs, which are stored in the sides. And if you look in here, you can align the peg with the corresponding hole tight against the wood, and then rotate the cams to pinch the block against the wall here. When you set up for a cut, you want to start by putting it in the slot for the angle that you want to cut, and then you want to make cutting motions in the forward direction. Important to note are the alignment of the teeth again. So when you're making cuts, you want to be cutting only in the forward direction, and then you can gently pull the saw backward in the back swipe.
When cutting polycarbonate, we recommend that you use a back saw and a miter box, just like this. The back saw has a rigid spine that allows you to get a much straighter cut. In addition, the spine of the back saw prevents it from going too deep and cutting through the miter box.
Next, we'll talk about using the hack saw, which can be used for aluminum or polycarbonate or other hard materials that we've gotten in G34. Again, paying attention to the directionality of the blade, we want to make sure that we're cutting in the correct direction. On these nice DeWalt blades, there's an arrow indicating the direction that you should be pushing. So I've already set up the piece of aluminum here in the table vise. You want to orient this vertically and give yourself about an inch of clearance before you start, or from the end of the vise before you start making a cut. To start your cut, you can put your hand on the opposite side of the hacksaw and then slowly move through the material. Tension in the blade is critical, so if the blade starts bowing on you while it's in the material itself, starts moving around, on these DeWalt hacksaws, you can slide this back, pop this open, and then increase the tension by twisting this knob and replacing it. That technique can also be used to change a dull blade and to switch the orientation of the blade itself. To prep your piece for drilling a hole, you can make a punt or a hole indicator on your piece by etching with the calipers, and then taking the center punch lining it up with the cross and making a dimple on the surface there. It's important to note that this is a technique that should only be used on harder materials like metals or maybe on wood, but on brittle materials like plastic, it can fracture your piece. But on brittle materials like plastic, it can fracture your piece. Next thing to do is properly secure the material to the bench. So you can take a clamp like this, fix it to the table so that it's firm. Next, select the bit that you want to use, and then get it into your chuck. So the way you can do that is by moving the collet relative to the chuck itself, which moves this collet in and out, so you can get it to the appropriate size, and then twist this into place. And you want to wait to hear that click. Then, make sure you're plugged into your GFCI. Align your drill bit with the dimple that you made with the drill punch. Verify first that you're moving in the correct direction with this switch here. So make sure you're moving in the clockwise direction. Align the tip with the center punch dimple. And then apply some force with your shoulder from above as you slowly start the cut until you penetrate the surface. Make sure when you're doing this that you do this only on this plywood to prevent drilling straight into the table. Once you're done, you want to carefully remove the shavings from the work area before you can unclamp your part. To clean up your edges around a larger radius hole, you can use a deburring tool like this one to cut right around the edge. It'll give you a nice clean cut.
So if you want to drill a big hole into a piece of sheet metal like this, you're going to want to use a smaller bit, because if you start drilling with this, it'll start to deflect and walk over the surface. So we're going to handle this by using a guide hole with a smaller bit. You want to place the bit into the chuck of the drill and tighten. Wait until you hear a clicking sound and you're ready to go. What you don't want is for the bit to be sideways like that, because that can spin out of the drill and be unsafe. Also, if you're trying to drill, it probably won't work. So we're going to go ahead, put it in nice straight up and down, and we're going to drill our guide hole. And now we're ready to use the bigger bit. It's very important to hold your aviation snips the correct way. Notice how these two handles are quite different. This has a thumb holder, this has a finger holder. Put your thumb under the thumb holder and your index finger on the finger holder, and that's how you know you're holding them correctly. So to cut a piece of sheet metal, you want to mark the line that you are going to cut. So you can do that using one of these two utensils, either a scribe or a Sharpie. I prefer the scribe. It has a sharp metal tip and is used to etch the metal. So we're going to take the T-square and mark a nice straight line along the sheet metal. In order to cut the sheet metal, we're going to use compound action snips, which are also called aviation snips because they were originally used to cut aluminum in airplane construction. So we're going to put on our gloves because the sheet metal is very sharp. And we're going to start slowly and take little snips when we first start and cut right along the line that we marked. Notice how when I'm cutting, I'm always taking little snips at a time. That's because you always want to be cutting close to the interior of the jaws. What you don't want to do is compress it all the way down like you would a pair of scissors, because you get a bend in your metal like that. Be very careful while cutting and keep your fingers away from sharp edges and the blade of the aviation snips. You always want to keep them behind where you're cutting and never move close to the blade. So the piece of sheet metal that you just cut could be very sharp still around the edges, and there may even be a few bends at the corners. So what we're going to do is place it on an anvil like this, and we're going to use what is called a ball peen hammer, which gets its name from this funny looking ball over here, which was used by blacksmiths back in the day. And we're going to hammer down on the edges. Once those are pounded down, we can also file down the edges and dull the corners using a file like this. So once you have a nice hole in a piece of metal like this, you may want to tap it so that you can thread a screw through it. To use a tap, you want to put the tap into the tap wrench and tighten the nose cap like so. You want to get it nice and perpendicular to the surface and slowly thread it in like you would a screw. It's important to keep it straight up and down so that you don't get a diagonal thread. And as you go through, you also want to back it out every now and then, so turn it counterclockwise. This helps refine the edges and get a perfect thread. So to know if you've tapped the hole well enough, you should be able to thread a screw such as this one through. As you can see, you can tighten it with your fingers, and that is a perfectly tapped hole.